Alright, in this quick video, I'm going to talk about the internal structure of the Earth. This is the first part of the plate tect chapter. This is foundational, right? It is not difficult, but it does require a bit of memorizing. If you look at the syllabus document, what you need to know about the first part of the plate tect chapter is the internal structure of the Earth. It says you need to know what is the core, the mantle, and crust. Notice, if you read it carefully, it doesn't say that you need to know about the asthenosphere, the lithosphere, and all those other Greek terms. Although your textbook has them, what's most important is the core, the mantle, and the crust. And under crust, you see continental and oceanic crust. So it's not complex. Let's go back to the PowerPoint slides. Right, you would have learned in class that it's similar to a Ferrero Rocher. It has different layers. The core is like the fudge in the middle, and then there is the crust that's like the layer of peanuts and biscuit at the top, and things like that. Right. This is a very familiar diagram to you by now. Let me run through just the key points. Right, I don't have time today for all the details of how hot it is and all that. But I just want to pull out the key points in these 3 minutes. Okay. First, the core is made of iron and nickel. We call it the knife, N-I-F-E. So the knife is made up of iron and nickel. What's important is basically that it's 3,500 km thick. Okay, and it's made up of a solid core. And a solid inner core and a liquid outer core, right? What's important about the mantle is that it's made up of mostly solid rock. Okay, think of it as something that's solid and yet can flow, right? It's made up of mostly solid rock. It's 2,900 km thick. It's divided into the upper and lower mantle. Now, this is an important part of the 3 layers because this is where we live our lives. And this is the thing that causes all the landforms and earthquakes and things like that. It is the crust. The crust ranges from 5 to 70 km thick. Typically, 5 km refers to oceanic crust. It's always thin. And when you look at continental crust, it's always thick. So it's a thin oceanic crust. Think of it as 5 km. And then there's a thick continental crust. Think of it as 70 km or to 75 km. Now, you can think of it as 2 objects floating on a tank of water, right? They're both floating, but you're going to find that the oceanic crust is like a wooden plank, whereas the continental crust is like a styrofoam board. When you push the 2 of them together, the wooden plank is going to subduct underneath the styrofoam block. And that's because if you put the 2 together, one is made of basalt and one is made of granite. And the oceanic crust that's made of basalt is going to be thinner than the continental crust that's made of granite. So when you converge them together, the one that's more dense will always subduct. Subduct, the word sub signifies under. You have subway, you have submarine. So the word subduct means that the denser oceanic crust sinks below the continental crust.